Okay, so now let's make a small example on calculating the sample mean or the arithmetic mean of a sample and the sample standard deviation. Okay, so by the way, I will talk also about the quartiles, which is in fact nothing more than the medians. Okay. So given these numbers, we will first find the sample mean. Okay, so the sample mean is again that's the arithmetic mean of these numbers. So it turns out that their averages, you sum them all and divide it by 15, which is equal to 5.67. Okay, so what's the sample median and the quartiles? Well, the sample median is you just order them from the smallest to the largest. Okay, and this is 1, 2, 3, 4, 5, 6, 7, 8. And this one, right, because you have 15 numbers, the one in the middle is the x8, right? So this is the median of the number. Um, so now, okay, so what is the quartile? A quartile, you have two quartiles. Okay, the first one, Q1, or the lower quartile, is the median of the lower half of the data. Okay, so what is the lower half of the data? It's sorry. Hmm. So it's this part. Okay, this is the lower half, and this is the upper half. Right. So what is the median of this data? The median of this data is simply 4. And what is the median of the other part, the upper quartile? That's 7. So Q1 or the lower quartile is the median of the lower half of the data, which is 4, and upper quartile Q3 is the median of the upper half of the data, which is equal to 7. So what is the standard deviation of the data? You simply just take the difference between the numbers and the average, which is 5.67, okay, and square them. Remember the formula? Square them and divide it by n minus 1 to find the standard deviation. Or we have another formula, which is, remember, just go back. I forgot it, but hmm, it's this one, xi squared times n minus xi. So you sum them up and take the square and divide it by n times n minus 1. Okay. So if you apply this formula, um, right? Okay, so we already have it. So sorry for going back. So s squared is equal to 3.095. So what is this? This is the per unit squared deviation. If you take the square root of this, which that's equal to 1.76. So what is this? On the average, the data is 1.76 units away from the average. Okay, that's what the standard deviation says us. And the sample range is equal to the maximum minus the minimum part. So that's equal to 6. Okay, great. And another definition is the interquartile range, which is the difference between the upper and the lower quartile. So the interquartile range is simply the difference between them, which is equal to 3. So let me show you a small example. So let's find, so there are three samples here. One sample consists of 357. The other one consists of 159. And the other one consists of 103, 105, and 107. So the average of them is this, the average of this one is 5, this one is 5, and the sample three's average is 105. Okay. Now let's try to find its standard deviation. So before finding this, what do you think about the standard deviation of the first data and the second data? Okay, so if you just look at here, so you have, okay, so let's say this is 0, 1, 2, 3, 4, 5. Okay, so 1, 5, this is 6, 7, 8, 9, and you have 10. Right, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, and the first data is here you have 5, and 3 and 7. Okay, this is sample 1. And if you just plot sample 2, you have again 5 here, but the other one is just there, 1, and the other one is there, which is 9. So which data has more dispersion? Which data is more scattered around the mean? Well, it's this one, right? The green part. So this has a larger dispersion when you compare with the sample one. How about sample three? Well, it's 105. Okay, so at first you might think that, well, its dispersion is high, but well, the thing is that if you just write, if you let me just change the color. So if you write this as 105, 106, 107, and this as 104, 103, okay? So this is the first data, this is the second, this is the third. So see, well, the dispersion of the third data is just the same as the first data, okay, the first sample. So what we can say is that, okay, see, these are the averages 5, 5, 105. This is the sample standard deviation. This is the sample standard deviation of the first and the second data. And it turns out that, well, the sample standard deviation for the third data is the same with sample one. Okay, so in fact, the standard deviation does not reflect the magnitude of the sample data. Okay, it does reflect the magnitude um, of the sample data, but it only reflects the scatter just around or about the average. So one last thing about this, let's say, variation is another type of variation is the coefficient of variation. Okay, CV or sometimes you see COV. Okay, it's in fact the deviation per unit average, the deviation per unit average. How do we find this? Well, it's equal to the sample standard deviation per divided by the sample mean, by the average. Okay, so what you find is the deviation per unit. Okay, well, so S and X bar are the sample standard deviation and sample mean. Um, we will talk about this later, but this is the standard deviation of a population and this is the mean of a population. So if you're calculating the coefficient of variation for the population, then it's equal to sigma divided by V. And sometimes it is multiplied by 100 because it shows the percent of, let's say, it somehow shows percent of a data. Okay, or you report the coefficient variation as a percentage. So assume stock A and B's yearly return has the following average and standard deviation values. Okay, so what can you say about their deviation? So as you see, the stock A has an average of 20% yield. Okay, but B has a larger return. Okay, its return is double of that of A. However, the standard deviation of A is equal to 5%. Okay, its yield has a standard deviation of 5%, but B has a standard deviation larger than A. Okay, so this one has a larger average, but this one has a lower standard deviation. By the way, in financial, let's say, analysis, if you have a smaller deviation, it means that you have a smaller risk. So this one has a small risk, this one has a larger, let's say, yield. So in order to compare this, one way is using the coefficient of variation. Okay, so the coefficient of variation here is, let's find the per unit standard deviation. Okay, so that's equal to 5% divided by 20 average. That's equal to what? 1 over 4 or 0.25, or which is 25%. This is CV of A. How about CV of B? That's equal to 20 divided by 40, which is equal to 0.5 or 50%. Okay, so this is the coefficient of variation for B, and this is for A. So this one shows that, well, the deviation per unit income is larger in B, which means B has a larger, let's say, standardized risk when you compare with the stock A. Okay. Well, we have covered two important measures of a data set, the average and the dispersion. Remember, we say that um, can we find some numbers summarize, which summarize the properties of the data, okay? So the average and the dispersion, okay, these are two very important measures which summarize the data. That is, if you know the average of a data, then you know pretty much uh, enough information about the data. If you even know the dispersion or the standard deviation, well, you really know very fine information about data. Okay. So, is there any other measures? Well, yes, not as important as average and dispersion, but we also have uh, shape, let's say, shape of the data or shape of the distribution. So this is what we call a symmetric shape. Okay. So here you have the average of the data. That's also equal to the mode and the median, right? And but if the data, if more of the data is accumulated at left, okay, so this is what we call a positively skewed distribution. Okay. So here the mode, so this is the mode. Remember, the mode um, is the is the most frequent one. By the way, this is somehow the probability mass distribution of this data. Okay, or well, this is the, let's say, this is in fact not f but okay, so we are talking about the sample data. So this graph shows you the ni, which is the frequency table. Okay, this is the frequency table, or this is the frequency plot. So the mode is here, the median is somewhere here, and the average of the data is somewhere here. Okay, so this is what we call a positively skewed distribution. There are several measures for this. Okay, there are several measures for this. We won't get into the details, but please just know that, well, shape is another type of important measure for the data. So of course, the data may be just uh, so let's say a large portion may be accumulated at the right part, okay, which means then this is what we call a negatively or left skewed data. So this is positively or right skewed, okay, right skewed, which means so the data is accumulated at the left, and so this part, this thin part just goes to the right, and this is vice versa. You have the thin part here, okay, and the most of the data are accumulated at the right part, okay.